Hi guys, we're going to talk about design of shear reinforcements today. In this video, I'll be talking about how the steps of how to design a shear reinforcement when a question is given to you. Now let's check out the procedure. The first step is we check out the shear force value given. If it is mentioned ultimate, factored or design, it will be denoted as VU. Here in the question we'll be using ultimate force throughout. Now suppose if nothing is mentioned, that means the actual shear force is given to you. So to get the ultimate shear force, we multiply it by partial safety factor. So VU is equal to actual shear force into partial safety factor. After that, we find the percentage of steel by using this formula. PT is equal to 100 into AST by PT. With the percentage of steel, we can find the corresponding values of shear stress imposed on it and the shear stress of the concrete. Also, it depends upon the grade given to you. Oh, and when the shear force value, suppose these three are not mentioned and it says shear force at the ends, that means shear force at the supports. In my previous video, I mentioned that at the support shear force value is maximum. So the four things that you have to consider to see whether U is directly given to you, check if it is ultimate, factored or design, or if it is mentioned shear force at the supports. That means VU, that is the ultimate force shear force value, is given to you. Else multiply it with the partial safety factor and we'll get the ultimate shear force that we need. Then we find percentage of steel. After that, we find the nominal shear stress τ, that is the shear stress subjected on it. VU by, with the formula τ is equal to VU by BD, where VU is the ultimate shear force and B and D are the effective width and depth. After that, we find the shear stress of concrete, that is τC. It is determined by the corresponding value of percentage of steel as well as the grade of concrete given to us in the IS code 456-2000, table 19, page 73. After that, we find the value of τC max, that is from table 20 in the code itself, IS 456-2000, and it depends upon the grade of concrete. Now why we are finding τV, τC and τC max, so that we can check out if the beam requires additional reinforcements. That's why we are finding out the values of the shear stress imposed on it, shear stress of concrete, as well as see how much shear stress it can handle, that is τC max. Okay, now we check out the condition. If τV less than τC less than τC max, then we don't have to provide additional shear reinforcements. We can directly find spacing. SV is equal to 0.87 Fy ASV into T by 0.4 BD. Here, when we find the value of the spacing, make sure it is in the the multiples of 10, so that the value will be more accurate. Usually the spacing between these stirrups are kept minimum, so that we can avoid bending. So when you find the value, make sure just round it up in the say it's 124, you round it up to 120, so it can be more accurate. Here B and D are the effective width and depth, and ASV is the area of the vertical stirrups, and Fy is the characteristic strength of steel. After that, I mentioned that the value between the stirrups is minimum. So it should not be too far, not too low. If it's too far, what's going to happen is a bending will take place. So there will be a maximum spacing of how much spacing you can give when you find the value. So we check out the maximum spacing for stirrups, 0.75D or 300 mm, and we take the minimum value out of it. Usually the value between the spacing between the stirrups are kept minimum, so we take the minimum value after comparing the two values that we got. We take the minimum value spacing for stirrups. Now suppose if τV is greater than τC, that means the shear stress imposed is greater than the shear stress of the concrete. what's going to happen is that cracks will take place. So to avoid cracks, we provide additional reinforcements. So when we provide additional shear reinforcements, we have to first find out the shear force value of the ultimate shear force value of the shear reinforcement, that is of the deformed bar that we've used. That is the how much it can withstand. So the shear force value PUS is equal to VU minus VUC. We have the ultimate shear force value. Subtract it from the using VUC, that is the shear force of the concrete. It has a formula tau C into B into D. DUC is equal to tau C into B into D. So we substituted VUS is equal to VU minus tau C into B into D, where VUS is the shear force of the stirrups. Okay, we found the value of VUS. Now we substitute it to in the formula of spacing. But for when we provide additional shear force, means it depends upon what type of stirrup you're providing. So the spacing formula changes. The spacing formula also changes. So for vertical stirrups, usually throughout vertical stirrups has been asked. So SV is equal to 0.87 FY ASVD by VUS. For inclined stirrups, once inclined stirrups question was asked, SV is equal to 0.87 FY ASVD sin alpha by VUS into sin alpha plus cos alpha, where alpha is the inclination of the bars that has at which angle it has been provided in the beam. And rarely for single bars it has been asked. SV is equal to 0.87 FY ASVD into sin alpha. You don't have to worry about memorizing the formula, it's given in the code. Usually vertical stirrups has been asked throughout when we are providing additional shear reinforcement. After we found the spacing, we rounded up to multiples of 10. Then we find the maximum spacing of stirrups, which is 0.75 D of 300 mm. Then we take the minimum value. Now in both conditions, we have to find the spacing of the midspan. Just in case if the question asks to find the spacing of the midspan, we take VUS, that is for vertical stirrups. VUS is equal to 0.4 BT. That is our usual formula, where 0.4 BT, that is the minimum reinforcement. Then we check the maximum spacing, and then we take the minimum value. Okay guys, so that was all about today's video. I hope you've understood how we design a shear reinforcement when a question is given to you. These are the steps. So with this I would like to conclude. Thank you.